Okay. Good afternoon, everyone.
Good afternoon.
In our last class, we were discussing about the denial of service attacks, and in those attacks, we had covered till now the Smurf attack, Ping of Death, Teardrop, and Sin Flood attack. So, normally, as of now, we had found that some of the major points that uh, as of now, you are having only one attacker and one target system. Now, your attacker can either be a legitimate user or a non-legitimate user who is technically termed as an intruder. Also, the presence of a intruder can either be within the same network or it can be outside the network of the target server. Okay, here the denial of service attack is normally said as you are restricting the legitimate user to access the resources which are dedicated to for the uses of that particular user. Also, what are we doing is we are exhausting the resources of the target server and making the target server busy in doing unwanted stuff which would further degrade the performance of the target server, and with the time the target servers uh, capacity would also get decreased and it would collapse. So as of now, the intention of the intruder is just to exhaust the resources of the target server and collapse it. Okay. So moving forward with the attacks which we had discovered till now, the other category of denial of service attack is referred as a DDoS or a distributed denial of service attack. So here the notion of attack is that there would be multiple attacking sites which are attacking a target server. Okay. So here what is being done, that for an attacker it is very convenient to distribute some sort of a malicious code into the host of the system, and when the so there is one major attacker or a malicious party who is actually trying to induce some section of code into the other host machines. So here what is being done, that the section of code which is being introduced into those hosts is referred as a Trojan. Okay, so Trojan is also a malicious component. Now the Trojan has a characteristic that it gets triggered depending upon certain condition and then it gets activated. Fine. It is not necessary that if a system has Trojan within it, or if a system has something which is a code and is corresponding to a Trojan, it would always infect the system. It would only be infecting the system when there is certain triggering condition on which that particular Trojan depends upon is triggered, and then only that malicious code would execute and affect the system performance. Fine. So, what are the possible sites where you can introduce a Trojan? Normally, it is said that there needs to be some vulnerability into the system so that it can be exploited by introducing the Trojan within that particular host. And once you have exploited that vulnerability, there would be some possible event which would trigger it and affect the particular host. Okay. So for a malicious party, it is normally said that it is very easy to identify the vulnerable points into the host, use those vulnerable points to introduce the Trojan and exploit those machines. Now, here, what is done in a distributed denial of service? Normally, uh, this is the case where you will have a malicious party who need not be present onto the same network. He can be present on the network which is outside the system. So what would he do? He would identify some hosts which are the legitimate hosts. Okay. So he'll identify the host into the not legitimate host. Here we are saying that there are legitimate clients. Okay. The host are the ones within which your clients would log on and send in the information or request the information. Now, these hosts or are the machines the host machines which will now have Trojan with into it. Okay. Now, the Trojan or the malicious code which is embedded or sent to these zombie machine can either be same code or it can be a different code. Okay. So if it is a same code, what does it mean? That uh, all of these machines would behave similarly depending upon the code which has been inserted. So let's say the Trojan which is inserted has the information that once the Trojan gets triggered, it would send the ICMP packet to the target server. Okay. Now, it is not necessary that all of these machines would send the packets at the same time because we said that Trojan triggers on certain conditions. There can be a possible situation where the triggering of the Trojan happens at some other time at each and every a host. So, what would happen? The host would send in the messages to the target servers. Okay. Now, sending the IP ICMP packets would also involve spoofing of the IP addresses. Okay. It can involve pinging the entire network or sending synchronization packets. That depends upon what all packets you want. So here we are only concerned upon what is actually DDoS. We're not specifying that only for this packet DDoS will occur or only for this packet DOS will occur. It can occur for any packet. Okay, because we are exhausting the resources. So exhausting of the resources or utilization of the communication channel can be done by any of the packet. So here the malicious party has inserted these Trojan into these machines, which are now referred as zombie machines. These zombie machines will now send the packets to the target server. So these zombie machines are actually sending the packets on behalf of the malicious party. Okay, then the same thing comes over here. They would send the packets to the target server by consuming the entire available connection capacity, thereby using the entire network bandwidth, not allowing the legitimate users' requests to be satisfied by the target server, and finally decreasing the performance of the target server and making the target server incapable of satisfying any other requests, whether from legitimate or whether from a non-legitimate user. Okay, so here what is written that after choosing a victim, a signal is transmitted from the attacker to each zombie machine to initiate the attack. Clear? So this is the thing which happens when a DDoS attack happens. Okay. So these from malicious party to zombie machine is referred as DDoS. So technically the overall thing would be referred as a distributed denial of service attack. Clear? Any doubt?
मैम मैम zombie
Yes.
zombie party is related to malicious party. Zombie
Uh,
machine.
Related in what context are you saying?
Ma'am, because of the malicious party, the it gives the zombie machine gives the target server some
Mm-hmm.
malicious signals.
Mm-hmm. See, I cannot say that it is related to you. Assume this case that uh, in your network, your system is a malicious system and it is trying to launch the attack on other servers. Okay, so technically both of you are present in different network. Now, what you want to do, you would try to identify those systems which are present on your server's network, जिसको आपको target करना है. तो आप क्या करोगे? You do not want your system to launch the attack on the server directly. So what would be the best possible way is you would try to identify those machines present in the target server's network which are vulnerable. Okay, and make them as zombie machines. Okay,
Okay, ma'am. Okay, ma'am.
any other doubt?
No, ma'am.
Fine. Now,
No, ma'am.
talking about defenses, you can have defenses in a distributed DOS attack at multiple sites. Okay, so I'll tell you some example. Wait. The whiteboard is visible to you all.
Yes, ma'am.
Okay. So assume a case where this is a site which has, see, my drawing skills are not good, so sorry. Um, these are four systems. Okay. Within these systems, this can have servers. Now I have two server over here. This is, let's say it's a normal node N1 and it's a normal node N2. Okay. So we are trying to visualize a scenario which is referred as a DDoS, distributed denial of service attack. Okay. So this is an open internet which will have multiple servers, multiple nodes. The servers S1 and S2 can be end servers, it can be file servers as well. It can be file servers. Clear? So this is an open internet. So as of now, open internet includes your systems, my systems, everywhere system. And this is one server, which is the target server. Fine. So this goes with the scenario that in a DDoS, you are having multiple machines which are targeting single machine. Clear? So this is a case of, you would find it represents a funnel. Okay. So the mouth of the funnel has all of the nodes which are originating the packets, and all of these packets are originated and sent to the target server. Clear? Now, there can be a case that whatever packets are being flown from here to here, that is, this is my source and this is my destination. This is my source of traffic and this is my destination of the traffic. This is the source of attack, and this source of attack is targeting the destination server. Clear till now?
Yes, ma'am.
Okay. Now, if I try to develop a defense, I can develop the defense at the source end. So this is referred as developing my developing my defense at the source end. I can also have the defense at the destination end. Clear? If I have the defenses developed at the source end, these will be referred as source-based defense mechanisms. If I have my defense at the destination end, it would be referred as destination-based defense mechanism. Okay. Now, what is the need of having two defense mechanisms? Or why were we having two explicit mechanisms of developing a defense for DDoS? See, it is said that it is said that this entire mouth or this entire open internet will have the traffic originated to this destination and sent to this destination. Now, you cannot classify that N1 is sending traffic, which is malicious traffic, or N2 is sending malicious traffic. You will be having multiple amount of traffic being sent to this particular destination, and into that traffic which is being sent to the destination, it is very difficult to categorize that this is the entity which is sending malicious content and this is the entity which is sending normal content. Okay. In the previous example which was there into your slides, what was it doing? Here the malicious party had triggered or made some of the host machines as zombie machines. Okay, so it doesn't mean that only those machines will be sending the data. Clear? There will be other machines as well into the host who would be sending data to the target machine. Okay. Now, in the entire traffic which is being flown from the open internet to the target destination, if you want to develop a defense, what can I do? If I had the information that node N1 is sending the malicious traffic to the target server, I would develop a defense at node 1's end. तो जितने भी पैकेज नोड 1 से जाएंगे वो हमेशा फिल्टर होकर ही जाएंगे या फिर किसी रेट पर जाएंगे. उसके कारण क्या होगा, मेरे टारगेट सर्वर पर अटैक नहीं होगा. क्लियर? एनी डाउट टिल नाउ? Any doubt?
No, ma'am.
Anybody else? Sure, nobody has doubt? Okay, I'll go ahead. So that case of finding out that N1 is the only entity which is sending malicious traffic, it's a very rare case because you would be having multiple traffic originators at the open internet. And if I go with that scenario that I would try to have a defensive mechanism at each of the end, it would be very time consuming and not at all cost effective. Because for adding a defense, what possible defenses, say the first thing comes in, what possible defenses could be there? One defense can be there that I can have a filter, जैसा हमारे पास firewalls जैसा होता है. So I'll try to have a filter at each of these end so that it filters out the packets. Okay, so we heard that one of the possible packet which can launch attack on the target server is ICMP packet or ping packet. So I can have a filter at individual end of the nodes or individual end of the server that not more than 5 ICMP packets or not more than uh, n ICMP packets are sent from this particular node. If they are sent, then the rate at which these packets are sent can be minimized with the help of these filters. Or the other thing, what can I do is I can add a filter which tries to identify whether the outcoming packet from that particular node always has his IP address or not to prevent spoofing. So developing a defense at the source end might give you advantages as well as disadvantages. Talking about disadvantages first is that if I'm developing a defense at the source end, I will have to develop it at the individual traffic originators end. Clear? If I would have to develop it at the individual originators end, it would be very cost ineffective. That is, it would not at all be optimal. Okay, so obviously this plan is discarded that I will not have it at the end interface and you at the interface of each of the device. The other possible location of source-based defense could be somewhere outside this. So somewhere outside this open internet, which is very near to that open internet. So whatever traffic comes from all of these devices, I will have a common defense mechanism which is referred as source based. So this is the location कि सारी जितनी भी nodes present है मेरे open internet में कहीं जाकर के उनका traffic यहाँ पर filter out हो जाए. Okay, now whenever the traffic is originated, okay, so let's say here only N1 is sending the traffic, which is malicious traffic, and the other nodes which are sending is the which traffic is the legitimate traffic. So at this end, if there is a source based defensive mechanism, here what could happen is the ratio of legitimate packets will be larger than the ratio of non-legitimate packets. Clear? I said that N1 is the only node, ये मुझे पहले से पता है, ठीक है? N1 is the only node which is sending the non-legitimate traffic or which is behaving maliciously, and the other nodes which are sending are the legitimate nodes and sending the legitimate traffic. So here the ratio of the packets which are from an intruder is much lesser than the ratio of the packets from the legitimate user. Clear? If I add filter at this end, the maximum amount of packets which are filtered at this end will be which one? Legitimate or non-legitimate?
Non-legitimate.
Non-legitimate. हमने फिल्टर ऐड किया. अब फिल्टर हमारा हमेशा फायरवॉल्स हमारे हमेशा वैलिड तरीके से तो नहीं करते ना. देयर आर केसेस वेयर दीज टर्न आउट टू बी फॉल्स पॉजिटिव, देयर आर केसेस वेयर दीज टर्न आउट टू बी false negative. So here when you are filtering, that filtering might involve dropping of the packets. So the packets which possibly can be dropped can be non-legitimate packets as well as there can be legitimate packets. You cannot characterize or completely say that always all of the packets which are dropped would be the non-legitimate packets. Clear? So there is very uncertainty in saying that all of the packets which will be dropped will be the non-legitimate users packet. There is a possibility that the legitimate users packets are also dropped. Okay, so what did we do is we tried to shift our defenses to the destination end. Reason is that the traffic here, which is actually a intruder's traffic, would be higher over here, and the traffic would contain larger amount of intruders packet and the lesser amount of legitimate users packet, because it is a DDoS scenario. It's a DOS, denial of service attack scenario. So at the destination end, the ratio of non-legitimate users packets would be much higher than the ratio of legitimate users packet. Okay, so we'll try to have a defense at this location as well. So this is just a trade-off. If you have it at the source end only, it would provide you advantages as well as disadvantages. If you have it at only destination bin, this would also provide you advantages and disadvantages. Okay, so one other way can be you can have it in between, that is at the network interface where you have all of the routers. Okay, इसका भी advantage disadvantage होगा. One advantage would be that the routers can possibly have filtering mechanisms which filters out the spurious packets. But the disadvantage is that the rate of flow would be compromised in this case. Every time when a packet comes at the routers, it would process it and then send it to the destination. So thereby limiting the rate at which the packets needs to be actually arrived at the target server. So that is why it is not very effective to have individual source or individual destination or individual network based defenses. Instead, you can have a hybrid also. Okay. In next class, we will deal with what are the defenses which are individually dealing with source and destination. Each of the defenses which have been developed till now are effective, but these are not very 100% effective. Everyone would have some pluses and some minuses as well. But we need to clear out the fact that the maximum amount of attacks are prevented. We do not have any system that would completely isolate any attack into its existence. You will not have a system which would be completely said that it would always be prevented from DOS or it would always be prevented from DDoS attack. Okay, each of the defense mechanism, source, destination, network, or hybrid, will have some or the other method which would prove effective, but it might fail in some of the other cases. That is why there is a need of having using the defense mechanism with a motive that I would try to uh, have that defense which is suitable in my environment and which makes me utilize the resources in the most effective way and most efficiently. Though there is attack into my system, I would try to minimize the attack's effect. Clear? So coming up to the defenses, I can have the defenses at the source end, I can have the defenses at the destination end. But each of them has its own pros and cons. Clear? We'll go ahead with the details of what a possible DDoS attacks and the defenses are there into the system. But for introduction, just consider this case. Any doubt? Shall I go ahead?
Yes, ma'am.
Yes, ma'am.
Okay. So the other type of attack which can occur into the system, or it can be the outcome of a it can also be the outcome of a particular DOS attack, is privilege escalation attack. So normally when any intruder intrudes into the system, he intrudes into the system with a motive of gaining access into the server or any client. Okay. So normally when we say that any intruder has been given access, or it has attained access into the system, he would try to violate the uh, privileges which are there into the system for the clients or for any other host into this who has been enrolled onto that particular server. So here the privilege escalation attack is normally considered as the flaw which arises due to programming or due to the designing flaws. So we have two type of privilege escalation attacks. These can either be vertical escalation or it can be a horizontal escalation. Now, in case of a vertical escalation, the attacker grants himself the higher privileges. Okay, so now consider you are a normal customer of a bank. Okay, now when you are the normal customer of a bank, what can you do is, if you have been granted access to a particular server, what you can do is you can raise your privileges for a manager as well. Okay, so here a lower hierarchy person is escalating his privileges to a higher hierarchy person. This is referred as vertical privilege escalation. Okay. In case of a vertical privilege escalation, normally the kernel level operations are performed which allow the attacker to run the unauthorized code. Since you are already having a manager's privileges now, you can run any modifications which can be there, and advantages for you and disadvantages for the other consumers. Okay. The next one which is there is a horizontal privilege escalation. So here the attacker uses the same level of the privileges he already has been granted, but assumes that the identity of another user with the similar privileges. I'll give you an example for this again. You are the um, consumer. Okay. So now what you could have done, you could have raised your privileges. You did not do that. You could have converted yourself into a manager, and you did not do that. Now what you did is you violated the privileges of the someone who is already present at your level. So you violated the privileges of the other consumer. Okay. So both of you are at the same level. You are violating his privileges, and whatever operation is being performed by you, it is being said that that particular consumer has performed. Okay, so it is something which is very similar to IP spoofing, wherein you assume, sorry, you say that you are somebody X, and that X is sending the messages. That is referred as horizontal privilege escalation. So already it has been given an example that someone gaining access to another person's online banking account would constitute horizontal privilege escalation. Okay, now you have a buffer overflow attack. This is also a programming error or design flaw. So the very basic method or example to explain what is buffer overflow is this. So see, the it's a very normal C program which lets a particular user gets access into the system or not. So you have buff variable which is of size 15 and a pass variable which has a value 0. So you are prompting the user to enter the password, and the password which is being provided by the user is being stored on the basis of getS function and is stored in the buff variable. Okay. Now, whenever the value which is stored into the buff is stored, it should normally be of size 15. But whenever we are using getS function, getS already had the disadvantage that you do not have any bound checking done in the getS function. Whenever we use getS, it always gave us a warning. So here, what value is being provided into the buff is compared with the usage of strcmp function, that whether the value which is being given is the actual password or not. If it is there, sorry, if it is not there, it would prompt with the wrong password, and if it is the value which is there in buff is the actual password, it would print correct password, modify the value of pass from 0 to 1. Okay, and then you are again checking if your pass has been modified from non-zero value, then you are giving the root privileges to the user. Okay, so if I am a very naive user and I'm always performing in a given traditional way on the basis of rules, I'll always give the value of buff within 15 characters. Had I been very mischievous person, I would give random passwords or random values which are not within the 15 characters into that buff variable. Okay, so let's see what outcomes come in that case. So when I have the password given in the specified size, it gives me correct password and proper root privileges are given to the user. The next one is where I'm giving the values which are not within the range. So when I'm giving the values which are is not within the character 15, what happens is there are cases where inside the memory so you had two variables, one was buff and the other one was password. This was a character, this was an integer. Okay, so we said that 15 value was there. So 0 to 14 you have fixed for buff, and integer takes, let's say, 2 bytes. Okay. Uh, I'm just taking random values. So this is for password. Okay. So buff initially has nothing. However, your password has 0 within it. If you pass the values which is within the 14, it would not modify the password's value. However, if you pass the values which is greater than the 14 variables, or sorry, 14 characters, it there is a possibility that it overrides the value of password. So here when I provided HHH, which was higher than the 15 characters, there is a possibility. I'm only saying that there is a possibility because it is not necessary that buff and password are stored consecutively into the memory. Okay, so there can be other reasons as well on the basis of which your password can be modified. Here we are assuming this reason that buff and password are stored consecutively, and when I pass the values into the buff, which is greater than the 15 characters, the non-zero value, sorry, the zero value of password is modified with the non-zero value. Clear? There is understood? Any doubt?
No, ma'am.
Okay. So if it is a non-zero, or using the strcmp, it found out that the HHH is not equivalent to the geek stuff. Therefore, it printed wrong password. But when the control came into if password section, the password value, which was actually 0 initially, should have been modified to 1 when the password was correct, but did not get modified to 1. Instead, it was modified to a different non-zero value h. So if iska aska nikaloge, in that case, it would print root privileges assigned, even if you were giving wrong password. Clear? So this was the major flaw of having getS function. That is why we always prefer that when you are using a character as an input, you would use arrays for it. You need to have bound checking done into it. So that is why when you say that, uh, see here, what is it saying? Uh, hmm. See, you could either have considered, uh, what did I say? You could either have considered arrays, which are generally used for bound checking, okay? Or if I use a pointer, that would consider me the case that only this much size is required for a particular variable, pointer variable, which is of type character, and I would only read these variables based upon the addresses allocated to the values. So what happens in a buffer overflow attack is you are modifying the values of the variable with the context of size violation. Okay. Now, when you have violated here, in case of password, you had violated the value. You had violated the space which was designed to that particular variable. In this case, what can also happen is you are trying to access any location which is not dedicated for your variables, or which is not dedicated for your program. You could either reach to a location where you have the information about any private variable stored, or you have information about any return function which can be utilized by the intruder. The intruder can further identify some address space into your memory and use it to introduce new malicious codes or insert trojans into the system, because the intruder has gained access to a vulnerable location into your memory. Okay, that is the reason we normally try to have defenses from the buffer overflow. So you are overflowing the existing buffers which are there into the system and exploiting them by introducing malicious codes which would actually be executed uh, when the program starts its execution. So you cannot control the execution of such codes then. Okay, so that is why it is said that every time when we write any codes, these are the programming errors which needs to be taken care of so that the violation of the codes doesn't happen, or the violation of memories doesn't happen. Any doubt till now? Have you understood what is buffer overflow attack?
Yes, ma'am.
Okay, so we'll go ahead with this in next class. Okay, I'll send you the documents. You can go through it. Any doubt if it is there? Okay, we'll cover it in the Tuesday's class. Fine. Tomorrow it is Friday. It's off, so your lab won't be there. But you guys can do the assignments which I gave you that implement the what did I give? Implement the topologies, bus, uh, mesh, star, and ring topologies. Do this by the next lab, that is by Wednesday, and submit your assignments. Okay. You have time until Wednesday. You can submit it on Wednesday itself. What you will have to submit it, make a proper PDF where you have your codes, you have the outputs of the simulation, add the snapshots of the codes and the simulation which is done. Okay,
Okay, ma'am.
Yes, ma'am.
fine. We'll meet on Tuesday now.
Ma'am, tomorrow is holiday or we have no class?
Tomorrow is holiday. Tomorrow it's Friday and tomorrow it's Eid.
Okay, ma'am.
So that is why it's a holiday and you'll also not have class. Okay. My class will not have. I don't know about others will whether they'll be taking or not. Okay,
Okay, ma'am.
fine.